Welcome to another math screencast with Mr. S. We're continuing our geometry lessons, and today we're going to learn about the area of parallelograms. We're doing measurement and geometry standard 1.1. It's got double stars because it is a key standard. That means the state of California really thinks fifth graders need to know this. And what we're going to do is part of the standard, not the whole thing. Derive and use the formula for the area of we're not going to do a triangle yet, a parallelogram. That's what we're going to do. Later we're going to compare it, the triangles formula and the parallelograms formula, with the rectangle formula, and then figure out how to do them together. But for today, all we're going to do is the formula for the area of a parallelogram. So let's begin. Up here we have our formula. Area equals base times height. We remember in algebra, whenever two variables are next to each other or two letters, it means to multiply. So area equals base times height. So we have to determine what is our base and what is our height, and then all we have to do is multiply. So let's make our base, think of a basement, our base is the bottom. Okay, there's our base on the one on the left, and then here's our base for the one on the right. And then our height is how tall something is. Okay, and you notice that both parallelograms are one's upside down compared to the other one. It doesn't matter, the base and the height. All you have to do is multiply those. And what you're doing when you find area that you learned in 4th grade is you're finding the amount of square units inside the shape. Think of it like if you were going to put tile down on a floor. That's what you're doing. So, to show you an example, I'm going to erase my base and height, and then if I was going to put squares all the way down in my parallelogram, and they were all either inches or feet or miles, it's how many of those little squares are inside my shape. So that is why, since they're squares, that is why when we're talking about area, we're talking about a square unit. Well, what's a square unit? Well, a square unit means like square feet, square inches, miles, yards, centimeters, it doesn't matter. Square. So you'll see the word square in front of your unit, or you might see the little 2, because we know that the little 2 exponent means squared. So I might see feet squared, I might see inches squared, I might see centimeters squared, and that's how you know it's area, because you're looking for how many squares are inside the flat shape. Let's look at our first parallelogram. We're going to say that the height, which we're going to say is h, the height is 8 inches. And we're going to say our base is 10 inches. So to find the area of that parallelogram, area equals base times height. So we're going to say area equals base, 8 or 10, because that's in the bottom like the basement, 10 times height, which of our parallelogram is 8. So 10 times 8 equals 80. And since we said inches, we're going to put inches. We're always going to label our unit inches squared because it's area, or we can say square inches. So the area of that parallelogram is 80 inches squared. Now here it's upside down. Let's say, what if we put the base up here because it's upside down, and the height here? Same thing. The base is 10, the height is 8. 10 times 8, 80 inches squared. Okay, on this one, sometimes you'll see the parallelogram with the height on the outside. So that would be our height, and then this would be the base. Okay, so the base is here, the height is here. And let's say here the height is 3 feet. And here the base is going to be, I don't know, let's say 7 feet. Okay, so base times height, 7 times 3. Area equals base times height, 7 times 3. So 7 times 3 equals 21. And we're going to put feet squared, or square feet. So area equals that. There's the area, or the amount of squares that are in feet that would be inside that parallelogram. Another one, this time it's upside down. And let's say this time the height is 15, let's say millimeters. Doesn't matter what the unit is. And let's say the base, because it's upside down, let's say the base is up here. It doesn't matter. If the base, let's say, is, about 20 millimeters. And if that's 20, you could also say that's 20. So it doesn't really matter. It doesn't matter where the base is. It could be down here, 20 millimeters, up here. It's still the same amount. So 15 times 20, because area equals base times height. So area, capital A, equals base, which is 20, even though it's on the top, times 15. And 20 times 15 is 300. And we have to remember millimeters, so we're going to write mm. We'll write the little 2, or we can write 300 square millimeters. Okay, let's do another one. This time, it's all funky looking, and it's going straight up. It doesn't matter. The base and the height are still the same. Let's say this time, the base, which is actually here because it's turned around, if you look, if here the base is, let's say, 9 miles, and then let's say the height is 3 miles. Okay? Now you look at it and it might be a little confusing, but remember it's still the same. So if I move it here like this and move it, this one, which was our height, would go here, and this, which is our base, would go here. It's still the same, even if you turn it around. So let's turn it back the way it was, because sometimes you might see ones like this. 9 was our base. Our height was 3. Okay, so area equals base times height. So my base is 9. 9, my height is 3, times 3 equals 27, don't forget to label, miles. Okay, and what am I missing? I'm missing my 2. A little 2, which means squared. So I can say 27 miles squared, or 27 square miles. Sometimes you'll see the whole word square and the whole word miles written out. It's still the same. Remember, square miles. Okay, we don't put the 2. That 2 means this, square, so you don't need it 2 times. So, what we just did was measurement geometry 1.1. Just a reminder, we used the formula for the area of a, not triangle, parallelogram. Next, we're going to do the area of a triangle, and then once we know the area of a triangle and the area of parallelogram, we can use that information to figure out the area of a rectangle. Okay, but that's next. So all we did today was the area of a parallelogram. The music used for today's screencast was by Dr. Sam, Feelings Beats, Rock Beats Guitar, which was found on jamendo.com and used under the Creative Commons license. That goes the same with my screencasts. They are licensed under Creative Commons, so use them and share them as much as you'd like. See you next time.